This video is going to go over requested homework problems from section 2.5 on implicit differentiation. Usually we only take the top 3 problems, but because neither Ms. Schwartz nor I were not at class, I decided to do all 7 problems that you requested. Here we go. 19. Y equals sine xy. Here's how you do it. Let's take the derivative with respect to x, because that's what we need to do on both sides of the equation. So we're going to do a d dx here. We'll do a d dx here. And on the left side, we're going to get a dy dx because we just took the derivative of y with respect to x. On the other side, we're going to need a chain rule. So we have equals. We need the derivative sign, which is cosine. Keep the argument. And then multiply times the derivative of xy with respect to x. And the way you'll do that is you'll go ahead and do, I think you do first times second prime plus second times first prime. So let's stick with that. The first is going to be x, so we have x times the derivative of y with respect to x is dy dx, plus the second, which is y, times the derivative of x with respect to x is just 1. Okay, now dy dx isn't by itself though, so we have one more layer of necessity here. So we have dy dx equals cosine xy times x dy dx plus y. Okay, so now again we need to isolate dy dx. So what we'll do is we will move the dy dx's on one side of the equation. So we'll do dy dx minus x cosine xy dy dx equals y cosine of xy. So basically I took this term, I multiplied it, and I moved it to the other side. But then I also had to distribute the cosine xy to the y, and that's staying on the right side because it does not have a dy dx. So now to fully solve for dy dx, my final answer is going to be dy dx equals, so the top part will be y cosine of xy. On the bottom, we're going to have, if I take a dy dx out of this term, I'm going to get a 1. So that's going to be, a 1 minus, and then it's the rest of it. 1 minus this part, which is x cosine xy. Okay? That's what dy dx is equal to. That's what your first derivative is. And this is number 19. I say the trickiest part of this may be the product rule. It may be this green part up here. It's pretty tricky. The other tricky part is going to be, again, that factoring part. So hopefully this answered your questions if you asked for this problem. Also, schmutz on my board. Okay. 25. So here we want to find dy dx, and then we want to find the slope of the graph at a given point. Luckily for us, we already kind of did dy dx for this kind of function. So I'll just say that this is the first, that's the second. And let's go and set up our derivative. We're taking the derivative of both sides with respect to x. And what we're going to get, we'll do, again, first times second prime plus second times first prime. So first is going to be x times the derivative of y, which is 1, times, we just took the derivative of y with respect to x, plus the second y times the derivative of first is 1, times dx dx, which is just 1. Now on the other side, we get equals 0. So many students have missed this in the past, and we want to make sure that this year we don't get that. The reason we have equals 0 is because the derivative of a constant is 0. So please please be careful with that. Now, some students like to solve for dy dx. I like to plug in the point right away because, there's no reason why I can't. So I'm going to plug in -6 for x. I have -6 times dy dx. And again, I'm evaluating here, so I should show that. And then plus y. Y is -1, so plus -1. We have equals 0. So now if I solve for dy dx, then I end up adding this -1 to the other side and dividing by 6, so I get dy dx evaluated when we have -6, -1 is equal to -1 over 6. That is your answer. Again, another option here is if you were to just solve for dy dx, that would have been fine. I'll just show you that because that's probably what some of you did. And I don't want you confused. Yes, this is 11:42 at night. So if you solve for it, you get -y over x. You just want to solve for it right away. And again, when you evaluate, please make sure you're showing the notation. We're evaluating at -6, -1. And that is equal to a 1 over -6, which is what we got. Same difference. The only reason that I plug in right away, it decreases the risk of me making some algebraic mistake of combining variables that aren't supposed to be combined, factoring in a way that I wasn't supposed to. If you plug in the numbers right away, you're getting right to the point, and you're kind of saving yourself some time of doing unnecessary algebraic manipulations. So, heed the warning or proceed at your own risk. But we'll go ahead and go to the next one, 44. Okay, this is a good question. It says, explain why the derivative of x squared plus y squared plus 2 equals 1 does not mean anything. So when we say to take the derivative of x squared, or when we say to take the derivative of y, y squared, both of them are strictly one variable, and it's implied that you're taking the derivative with respect to x. So usually you would want to take, actually, let me erase this here because that would be contradicting myself. Usually when you say taking the derivative of a variable, you're usually saying like take the derivative of 50x squared. It's implied that the variable that you're taking a derivative of is the one that's in the equation. So here would be 2x, here would be 2y. But when you say take the derivative, and you don't identify with respect to what, you have no idea what it means. Do you want the derivative with respect to x? Do you want the derivative with respect to y? Do you want the derivative with respect to time? Because when we have more than one variable in the equation, when the equation is implicit and not explicitly solved for a single variable, then we have no idea what you actually mean when you say take the derivative. So this question is really just trying to get you to understand that when you take derivative with respect to something. That something could be an x, a y, a t, a theta, anything that the variable of interest is included, but especially when the equation is in an implicit form, you must state what you're taking the derivative with respect to. And I think I've said enough on that one, so we'll move on to the next one. Oh, fun. Let's take the derivative with respect to x for 49, and we'll have to do that twice. So let's go ahead and get going here. We'll take the derivative of this side, and I'll take the derivative of that side. Doop-a-doop-a-doop-doop-doo. I like doing videos at midnight. Okay. The derivative of 4 is 0. The derivative of y squared is going to be 2y and I took the derivative of y squared with respect to x, so it's a dy dx there, and the derivative of x squared with respect to x is always 2x as we know it. Let's go ahead and solve for dy dx, because that will make our life a lot easier. So let's just 2x plus, oh, nope, that's not right. Let's try that again, Mr. Lincoln. Now let's go ahead and go dy dx is equal to, moving the negative 2x over, divided by the 2y. That implies that dy dx equals negative x over y. Now that's not the final answer, it's just the first derivative. So now let's take the derivative, it's the second derivative with respect to x. So I'm going to do d dx of dy dx, and I'm going to take d dx of negative x over y. Okay, on the left hand we got that funky notation of d2y dx squared, and it's equal to, okay, low d high, because I need a quotient rule here, minus high, so minus the negative x times the derivative of the low part, which is going to be dy dx. And if you want to put a 1 here to just show the derivative of y is 1, but then you took the derivative of y with respect to x, that's fine. One of my hair is falling out. Actually, a lot of my hair is falling out. And then we're going to divide this by low squared, which is y squared. Now, a lot of students ask, well, what do I do with that dy dx? And that's a great question. First of all, let's clean up this first part. So we have negative y plus x times dy dx. And we have it over y squared. Well, let's see. Well, what is dy dx? This is Lincoln. It is not true. Dy dx is equal to negative xy, so let's just substitute that in. So we can get equals negative y plus x times, what was it? Negative x over y? Yeah! Negative x over y, then over y squared. And now you have to think, how do I get rid of that complex fraction? Because if this was a no calculator, multiple choice, 100% guaranteed that this answer right here is not one of the answers. So we would have to algebraically manipulate it to make it look like one. If this was a free response question, move on, you're done, please don't show off, go get the next problem. I want you to practice. I want you guys always to practice to make sure that you know how to manipulate these. So let's go ahead and just do that. d2y dx squared is equal to negative y plus x times negative xy. I'm just rewriting it over y squared. I'm going to multiply both sides by y. And what I end up getting is negative y squared minus x squared over y cubed. And the reason that happens is because when I distribute the y to both terms, this y cancels, and then this y is going to be 2 of them then. In the bottom, just y to the first times y squared gets y to the third. Other variations on the answer could look something like this. A negative in the front with an x squared plus y squared over y cubed would be fine. And again, I'm just doing this because I don't know what the answer in the book is, but I just want to make sure that you're aware that we could actually write this multiple ways. We could also write negative x squared over y cubed minus 1 over y. And perhaps the most fascinating, and I don't know if I'm going to actually do this, but I am, yeah, I'll do it. So if I went to the beginning of y squared is equal to the square root, y is equal to the square root of 4 minus x squared with the plus or minus to make the full circle, then I could actually plug that in here. And I'll go into, that's going to be ugly. Or I could also say that y squared equals 4 minus x squared. I think I like that one better. If y squared is equal to 4 minus x squared, look what I can do here. And I've seen this before, and it's just so cool. I get negative x squared plus, and we just said y squared is equal to 4 minus x squared. So y squared is equal to 4 minus x squared means that I can just substitute that in to get 4 minus x squared here with a 4 minus x squared at the bottom, because y cubed is y squared times y, and I think we said y was equal to the square root of 4 minus x squared. Wrote that wrong. Help me. So now what that can get me is 4 over 4 minus x squared times the root of 4 minus x squared with a plus or minus, or it could just get you plus or minus 4 over 4 minus x squared to the 3 halves. Again, I think they probably would have just wanted this one. That answer is probably the one that they definitely would want. But it's not far-fetched to think that they would want you to substitute what y was in the original equation. And it's not far-fetched that they want you to simplify common bases. So be careful with it. It's a tough problem when you consider all those different variables. Okay, let's go to 61. Find the points at which the graph of the equation has a vertical or horizontal tangent. Oh, my computer's going to die. That's going to be problematic, isn't it now? Let's plug in the computer. Oh, I'm just going to shift things around here in my makeshift office in the basement. Let's see. Oh, okay. If you hear a loud noise, it's because I fell. Okay. Okay, perfect. Alright, so now let's go and do this one. Find the points at which the graph equation has a horizontal or vertical tangent. Well, first thing I need to do is take the derivative with respect to x on both sides. Come on, don't do that. Okay, so let's take the derivative of that monstrous mess. Take the derivative with respect to x there. And my finger is dying, not sure why. On the computer it's dying, not in reality. That would be pretty bad if it was dying. Okay. Alright. So I get 50x plus 16y squared will be 32y dy dx. What is going on? Plus 200. It's like missing every other one. Minus 160. Oh my gosh, this is so annoying. Dy dx. This is horrible. Equals, the derivative of 400 is 0, and then equals 0. Oh, that looks awful. That's worse than my usual handwriting. Okay, let's solve for dy dx. I feel like there's a problem with the program. Okay, so dy dx equals, let's move everything over, so I have negative 50x minus 200 over 32y minus 160. And I could, if I wanted to, divide out of everything, so let's just do that because we can. That's negative 25x minus 100 over, oh come on, 16y minus 80. Okay, I'm going to reread the question to make sure I know what the question is asking, and it says find the points. Okay, so I need an x and y coordinate where there's horizontal tangents and vertical tangents. Well, for horizontal tangents, I need to set the numerator equals 0. Numerator equals 0 means I get x is equal to -4. Are you kidding me? I think I'm just going to start typing. The vertical tangent, oh, see, it's the vertical tangent is going to be the denominator set equals 0. When I set the denominator equals 0, I get y equals 5. So now I have to go back to the beginning of the problem and find out what the y-coordinate is when x is 4 and what the x-coordinate is when y equals 5. So let's do that quickly. So when x, this is going to be horrible. When x equals 4, I get 16, I get 400 plus x is 4, so 16y squared. Oh, God, this is going to be bad. Okay, plus x is 4, so 800. Alright, and then this is still no calculator for as long as we can see. Minus 16y, and then plus 400. Okay, well that 400 plus 400 plus 800 is 1600. So we have 1600 is 16y squared minus 16y plus 1600 equals 0. Okay, which means that I can divide everything by 16, so I get y squared plus y plus 100 equals 0. Okay. Let's just double check the math here before people start yelling at me. So this 4 squared is 16, that's 400, plus 16y squared plus 4 is 800, and it's 160. It's 160y. That's minus 2. Alright, I just need to do this on Word because I can't read my own handwriting here. This is bad. Sorry that you're going to hear typing. Slow typing too. Okay, come on, you can do it. Ah, November. That sounds important. Okay, so let's see here. We had 400 plus 16y squared plus 800 minus 160y plus 400 equals 0. Let's see what we get. 16y squared minus 160y plus 1600 equals 0. If I divide everything by 16, I get y squared minus 10y plus 100. This time that's right. 6 times 60 divided by 10 is 16. No, yeah, that's right. Plus divided by 16 is 100. Yeah, that's right, equals 0. Okay, so then that means that it's going to be factored into y minus 2. No, it's not. 25. Please don't tell me I have to do the quadratic formula. That's annoying. Shoot. Alright, let's just do it. 10 plus and minus the square root of 100 minus 4 times 100. That means it's not 1. Okay, interesting. All divided by 2. Interesting. Let's check this on decimals and make sure that that's true. That can't be true. I can't Google that. I feel like I just messed up on the 4 squared is 16. It's 400 plus 16y squared. That's another 4 is 800. That's 1200. That's 1600 for sure. Minus 116y. That's 16y squared minus 160y. That's right. And then you combine, I'm just looking over the work, y squared. So my math is telling me that there is no point, even though we got a horizontal tangent value at x equals 4, it's saying that there is no actual point of 4 comma something on the graph. see if that's right. 25x squared plus 16y squared. I love Desmos. Plus 200x minus 160y plus 400 equals 0. Oh, cool. It's a circle. Oh my gosh. Look at that. There is no point at x equals 4. There is a point at x equals negative 4. Oh my gosh. Okay, guys. I'm horrible. This actually did say negative 4, and I didn't catch that. And if it was negative 4, then that means that this part was supposed to be negative 800. Oh, that's so annoying. Sorry if you watched all of this. Oh, that's just horrible. That means that cancels. Oh, God, that's so annoying. Alright, let me clean this up. So this is supposed to be minus. So that's going to be 16y squared minus 160y. That's going to be y squared minus 10y. This is going to be. Okay, so it had to be at y equals 0. Nope. Y equals 0 and y equals 10. I want to confirm that with this picture. It is y equals 10 and it is y equals 0, so that's correct. Sorry that I botched that up, guys. That was pretty bad. Okay, so I have points at negative 4, comma 0, and negative 4, comma 10. That's where I have HTs. It's not really a bad process, it's just a lot of work. For the 5, let's do 5 for y now. So 5 for y means I'll have 25x squared. 5 for y, 5 is 25. That's plus 400. And that is going to be plus 200x. And that's going to be minus 160 times 5, so minus 800. Okay, and then it's going to be plus 400. Again, equals 0. So again, just like the last problem, the 400 minus 800 cancel. So now we just have 25x squared plus 200x. And when we get that, we can divide everything by 25 if we want. So that means x squared plus 8x equals 0. So x times x plus 8 equals 0, which means x equals 0 and negative 8. And I'm just going to confirm my results on the last one. And yes, I do. So when y is 5, x is 0 and negative 8, and that's where there are vertical tangents on this implicitly defined function. And again, I really apologize for botching that up. I couldn't read my own handwriting, but this was supposed to be a negative 4. If you're watching this all the way through, I'm very impressed. Last one. 70. Which is greater? The slope of the tangent line x equals negative 3. The slope of the tangent line x equals negative 1. Hard to tell. Okay, at negative 3, I have something that looks like this. At negative 1, there's something that looks like this. I don't think they want you to actually take the derivative, because that would be kind of annoying. Okay, what I did for you guys is I found the derivative with respect to x on both sides of the equation. I solved for dy dx. And again, feel free to pause at any point if you tried this on your own and you didn't actually get the right answer that way. And then I looked at the graph. So here's the picture of the graph. And I saw that there was a point right here around negative 3, 0, which is what it's asking about. And then x equals negative 1. They said that the y value was about 5. And then I plugged them into the derivative. And when I plugged negative 3, 0 into the derivative, I got a slope greater than 1. When I plug in -1, 5 into the derivative, I got slope less than 1, which tells me that x equals -3 had the bigger slope. And again, you could have eyeballed that. That would have been fine too. B, estimate the points where the graph has a vertical tangent line. So it looks like the graph is vertically tangent here, which looks like it would be anywhere from 2, 2 to -2, 2 to -2, 4. So basically, and that's not a very nice way to write it, basically we could say x equals 2, and for the y values anywhere, x equals -2, and for the y values anywhere between 2 less than or equal to y less than or equal to 4. And that takes care of all the points. The other one would have been the same thing, but a plus sign, because it's symmetric. So in fact, we could say x is equal to plus or minus 2. That would be a better way of writing it, and the most succinct way. So x equals plus or minus 2 for the same y values, 2 to 4. Where the graph is a horizontal tangent, well, that looks like it's right here. And that looks like x equals 0. The y value, because I need a point, is going to be 0, comma, looks like about 5.5. Okay, and that's it. I hope these videos helped, and I'm sorry if I went on too long. Thanks for watching.